Next we're going to talk about in our hot rod fuel injection system is fuel delivery. It doesn't do you any good to say buy a 450 horsepower crate engine, put it in your vehicle, but the pump in the tank is still stock. Probably the stock pump is not going to be able to deliver enough fuel to the fuel injectors in your 450 horsepower crate engine. So we have to consider that we're going to have to optimize the fuel delivery system to match the horsepower needs of our high performance modifications at the engine. So we have to consider, is our fuel pump big enough to feed the injectors, and are the injectors big enough to feed the engine? It takes fuel to make power. Obviously, the more air that we can put into the engine, the more power we can make, as long as we can match the fuel delivery to the airflow. So we have to consider fuel pump sizing. Do we have adequate feed and return lines depending on the horsepower level of the engine we're doing? And we have to consider the type of fuel delivery system of our fuel injected vehicle. There's basically three types. There is mechanical return style. The mechanical return style yields the best results in the high performance arena. For example, the fuel pressure regulator is after the injectors, and it's typically biased to engine vacuum. So if we add a supercharger or turbocharger, as the boost level comes up, it's also going to increase pressure to the fuel pressure regulator. Even a standard fuel pressure regulator that comes on a fuel injected vehicle from the manufacturer, you're going to get a 1-to-1 ratio. For example, let's say that engine idling, our fuel pressure is 30 psi because we have approximately 18 inches of vacuum to the fuel pressure regulator. Now, as we increase load, vacuum drops. Once we get to wide open throttle where there should be no vacuum, then we'll see a pressure increase of approximately 8 to 10 psi. But what if we went into a positive pressure because we've added a turbocharger or a supercharger? Well, we would get a 1-to-1 ratio, meaning for every pound of boost, we'd get an additional pound of pressure. This is known as delta pressure. As the pressure in the manifold increases, we need to increase the pressure to the injectors. Now, over the years, the manufacturers have all left the return style mechanical fuel delivery system and opted for returnless system. The problem is the returnless system, or the reason why that they went to the returnless system, is that when the fuel drops back into the tank, the hot fuel, it would churn up all the fuel and the vapors would put a heavy load on the evaporative system to control it. So now they don't want to dump that return fuel back into the tank and stir everything up. So now we use mechanical returnless. Mechanical returnless will find that the fuel pressure regulator is before the injectors and is not biased to engine vacuum. So now we're basically forcing our fuel through a restriction, a pressure regulator, and then it gets to the injectors. And if we do offer to the customer, or the customer has a supercharged or turbocharged engine, he doesn't have the benefits of delta pressure because we can't get the pressure to increase as the boost pressure increases. On these type of systems, I highly recommend that you do not go over 6 pounds of boost. If the customer wants a turbo or supercharger system that goes over 6 pounds of boost, you're probably going to have to add an older style mechanical return style with the regulator after the injectors and run a return line back to the tank, which is going to be an additional expense to the customer in labor and the hardware to convert it to a mechanical return style system. We're okay up to about 6 psi of boost, and then we just don't have that delta pressure, the discharge at the injectors, to make the turbocharger supercharger system work correctly on our fuel injected engine. The third type of fuel delivery system that we're finding very popular on the most recent manufacturer fuel injected engines is electronic returnless. Now we don't have a mechanical fuel pressure regulator anywhere. The fuel pump speed is controlled by an electronic module. The computer monitors the pressure and can send a signal to the module which controls the speed of the pump. This works out really nice because the tuner can tell the computer to tell the fuel pump control module to increase the pressure when you're under particular loads. So if you do add a supercharger or turbocharger to a fuel-injected vehicle that has electronic returnless fuel, it's easy for the tuner to go in there and increase the pressure, giving you delta pressure that you need at the discharge of the injectors because you can electronically turn up the fuel pressure. Even in the electronic returnless system, if you're running elevated boost pressures on your turbocharged or supercharged fuel-injected engine, you may need a helper. The helper that I'm talking about is called a booster pump. What a booster pump does is when we go into a positive pressure, it increases the voltage to the electronic fuel pump in the tank, and it can make your fuel pump put out 1.5 times its normal output by increasing the voltage to the pump. They're set up so once the electronic fuel pump booster sees the increased pressure above atmospheric pressure, that it goes on and increases the voltage, say, to 17 or 18 volts to the electronic fuel pump in the tank, and then you get your delta pressure. The newest fuel injection system that's about is gasoline direct injection. In 2014, the Chevy Silverado and the Corvette were the first pushrod engines to have gasoline direct injections. Well, of course, enthusiasts are already putting superchargers and turbochargers on the new small block Chevy gasoline direct injected engine. Here's the really nice thing. They're adding a supercharger which its main job is to add air. With the GDI system and the robustness of the injectors delivering fuel pressure into the cylinders up to 2,900 psi, the large low pressure in-tank fuel pump and the fuel pump control module, most of them have the capabilities of 90 psi or greater, feed to the high pressure pump. All the tuner has to do to get the additional fuel delivery on a supercharger adding 8 or 9 pounds of boost is just do tuning. Just tell the existing in-tank fuel pump and the GDI system in the tuning of the program to give you the fuel that's necessary. So these new superchargers for GDI is making it real easy for the performance enthusiasts to add supercharging and turbocharging. There's no additional hardware, not even a booster pump, bigger injectors. We're just using the existing hardware and software on the vehicle, manipulating it in the tuning process, and we're able to see, I've seen on brand new Corvettes, 600 horsepower to the rear wheels. Not only 600 horsepower to the rear wheels, but these engines have active fuel management where they shut down 4 cylinders at highway cruise. This means you have an engine that makes 600 horsepower to the rear wheels, but is getting over 35 miles to the gallon. That's having your cake and eating it too in the high performance world. If the fuel-injected vehicle you're working with is a mechanical return-style fuel injection system, you'll have a fuel pressure regulator after the injectors. You can replace that fuel pressure regulator with an adjustable fuel pressure regulator. Now, when you change the pressure, you're going to be increasing the pressure to meet the demands of the engine. You're also going to globally change fuel delivery. So your tuner will have to make some adjustments to keep your long-term fuel trims in check. But at wide open throttle, this could be an advantage. Let's say that your performance modifications are requiring just a little bit bigger injector. Instead of having to buy a complete set of injectors, say for your 8-cylinder engine, which could cost $400 or $500, you may be able to buy a $50 to $75 fuel pressure regulator. Because when you turn the pressure up, you're effectively making the injector flow rate increase. Basically, you take your old pressure, divide it by the new pressure, and multiply it times the injector size. So most injectors are rated at 43.5 psi. So if you turn the pressure up, say 6 or 7 psi, now you're at 50 psi. You take the 50 psi divided by the 43.5, that new number times the size of your injector. Say it's a 24 pounder, and then it'll give you your new injector flow rate. It can save you some money if you don't need to go up the next injector size. I typically draw the line at 10 psi. If I need 10 psi of increase in fuel pressure, then I should consider replacing the injectors. But if I just need a little more fuel, somewhere between 1 and 10 psi, then an adjustable fuel pressure regulator will work really nice for you. Also, if you are turbocharging or supercharging a vehicle that has a return style system, you may be able to use what's called an FMU. This is a fuel management unit, sometimes referred to as a auto ranging or auto boost increase in fuel pressure, meaning instead of the typical 1-to-1, you may be 5-to-1, 3-to-1, 10-to-1. For every pound of boost, maybe you get an additional 5 pounds of boost pressure.